Welcome to The Real Build. I'm Jamila, your host. Thank you for joining us this week. And I have a very special guest. His name is Ben Station, owner, operator, chief construction nerd at Stationcraft, which is an energy evaluation company. Correct, Ben?
Yeah, we're an energy efficiency and engineering firm.
There you go. That is the appropriate description, straight from the chief construction nerd himself. I love that title. Today, we're going to be talking about energy efficiency and BC STEP code. Now, if you haven't heard of the term STEP code, it is an energy guideline that the BC government has implemented into building code standards. And what this is doing is step by step taking our building code standards and increasing the energy efficiency and energy use and output of our new construction homes, which is wonderful and great. But it is a journey. It is a journey. It has created an entire new segment within the construction world, which is energy advisors. Mm-hmm. And I've got Ben here to talk to us about it. But first, Ben, let's dive into your construction history. Now, you used to be, well, I guess you aren't used to be, you still are, a Red Seal carpenter.
Yeah, that's correct. I started my apprenticeship when I was in high school, actually, and went on to become a Red Seal carpenter. Spent about 20 years in the construction industry from that standpoint as a carpenter on site, as well as building homes start to finish.
So framing, finishing carpentry, tell us a bit more about carpentry.
Yeah, so I started my apprenticeship as a framer, and I've framed hundreds, if not 1,000 homes probably in my lifetime. 1,000's an overshot, but definitely in the hundreds. Mm-hmm. And then I moved from there, got more interested in all the different elements of construction. So I've done a lot of concrete work. I've done a lot of finishing, cabinetry, millwork, all of that stuff. So
not just a framing carpenter, not that framing carpenters are just, but finesse of a finishing carpenter.
Yep, absolutely.
Details.
Yeah, I think a lot of people in the construction industry go through this same type of evolution where you start in one field and then you start working your way into other fields, probably because you took on a renovation project that was a little too big and you had to do more things within it than you actually anticipated originally.
And then you either figure out if you're good at it or you're not.
Exactly. And then as you're moving into becoming a general contractor, you just naturally have a lot of exposure to the other elements of home building and being in the trades. And some people choose to specialize. Other people like me who get really bored really easily start doing a lot of the things within the trade and moving on and figuring out what they really like to do within construction.
Now, what took you down the road of energy efficiency? Because some people might think that is a really, really big shift from carpentry to energy efficiency. But
yeah, it is, and it can be. I'm not really sure. It's more of a value-based thing. Like I was very interested in energy consumption reduction living in Alberta at the time. Back then, we had a lot of coal-fired power and natural gas, and so there's a really big carbon penalty to building inefficient homes. So for me, it was an environmental thing that made me really interested in that. And then as I started to see the tie-ins between high-performance construction and the habits and the things that people were doing within the high-performance construction world, I realized that it's just a better way of building a house, not just for the improvements in energy efficiency, but also for the improvements in indoor air quality and occupant comfort. I don't know if you've been in a lot of high-performance homes, but when you're in a high-performance home and you have that level of comfort that comes from not having all of the things that negatively impact a home that is poorly performing, you really feel it.
Can you maybe break that down a little bit? What are some of the things you would feel in a home that is not performing at a high performance home?
Sure. I mean, the really common things that most people don't notice until they're in a different place are things like during the winter or even in the summer, when you're anywhere near the fenestrations, the windows and doors, if they are poor performing units, you you feel that in your skin as you're near them. When you don't have that same level of radiant reflection off your body and it's just going straight out through the window, you can feel that cold surface in proximity to you, and that leads to just an added level of discomfort. Now, and it's the same thing with an overperforming HVAC system. If you have an HVAC system that's having to blast a ton of air in order to keep up with the heating and cooling demands, that's moving the air a lot through the building and causing drafts, and it's also loud.
And I think that, like in something we'll talk later on in the show when we really dive into kind of new construction techniques, is you'll hear us talk about R values and R ratings of the walls. And a lot of people, I think we even need to break it down a little further, is when people think energy efficiency, they're thinking good performing furnace. They may have researched about heat pumps now, good performing air conditioning, and basically heating and cooling and high performance, high energy efficiency equipment. But in order for that equipment to be high efficient and energy efficient, the box that it's heating and cooling needs to be able to retain that heat or cool for a significant amount of time, not just be leaking it out into the universe.
Yeah, and that's why when you're on sites these days, you're going to hear a lot more talk about air tightness. One of the big things that's changing with the Energy Step Code is we're having to prove that our buildings are airtight now.
Yes.
And that leads to much more retention of that heated and conditioned air within the building envelope. So when we say building envelope, we're referring to the shell of the building, right? The walls, ceilings, fenestrations, which is windows and doors, and anything that makes up the exterior shell of the building. We want that to be tightened up. So when we talk about the building envelope, first and foremost, we're looking at a system of control layers, and maybe we'll get into that more later. But
well, and I think that brings us back to how Red Seal Carpenter develops a passion for energy efficiency, because you would think it's the HVAC guy, right? But no, your wall assembly and how that wall assembly goes together. For example, the seal he's talking about is literally a piece of plastic that runs around the home in certain ways. There's other ways to do it. But if you can imagine how many nails are going into this wall's assembly on the exterior, on the interior through drywall, if those nails penetrate that plastic, you now create a hole. So the art of putting your wall assembly together is actually an art these days.
It is, and it's very situationally dependent. It depends on the values of the client and what they really want for their own home. What you're referring to, like in the plastic in the building envelope, it's primarily done in Canada, where we use polyethylene sealed around the edges as our primary air and vapor control layer. That's not done as much in a lot of other places, but here it's done well and it's quite inexpensive, so that's what people end up defaulting to. But you're right, when you penetrate that air barrier, then you have potential for air leakage through the building envelope. And when you have air leakage through the building envelope, during the wintertime, you have warm, humid air from the inside leaking out through your wall, and that's carrying that humidity to points where the wall assembly is colder. Well, when it gets colder, it condenses, just like when you pull a can of Coke out of the fridge and set it on the counter, and you end up with all of this beaded water building up on the outside of it. That's because that surface is colder, and it's actually the moisture out of the air that's collecting and condensing on that can. So if you have that happening inside your wall assembly, that's how you end up with mold problems and indoor air quality problems and all of these things.
So he very elegantly led us into, one, we are talking about heating the universe, so air leakage coming out of it. But when you're trying to seal up your home, and you have small places that air leaks out, now you create water and condensation. So both challenges in wall assemblies while we're getting more and more efficient. We're going to keep talking about this. When we come back, we're going to dive into what Step Code is all about and energy efficiency and where we're going with construction. Stay tuned. Welcome back to The Real Build. I am your host, Jamila, and today we have Ben Station, owner-operator of Station Craft, energy efficient consultant, and we're talking about BC Step Code today.
Yep, we sure are.
So if you were with us before the break, we were talking how Ben has a red steel carpenter background, did a lot of carpentry, and got a passion for energy efficiency, which is easy to do because we're talking about how wall assemblies and air tightness is what truly makes your box energy efficient. And then the equipment you put in after that's going to heat and cool the box is going to what maintains that efficiency or increases that efficiency. So why do we care about efficiency? What's going on in the industry? If you have not heard of this before, step code, energy efficient step code guidelines have been implemented into building practices and building code in BC, not across Canada, just here in BC, because we are trying to create net zero ready homes.
Correct.
And so, Ben, maybe can you talk us through how this started?
Sure.
Yeah.
So when people think about building code, they'll probably be more used to thinking about minimum requirements, things you must do in order to make sure that the building is safe primarily. With the BC Energy Step Code, we're talking about things a little bit differently. Regular codes are what are called prescriptive codes. They will tell you what you must do at a minimum, and then you're free to exceed that, but that's your minimum set. For the BC Energy Step Code, it's actually a performance-based code. So what we're looking at is the values that you need to hit for the building as a whole over an annualized basis. So rather than telling you you have to have R20 walls, we're saying you can only use X number of kilowatt hours per meter squared annually to heat the house. And then we as designers are free to do whatever we want as long as we can make that model work and say, okay, you are only going to consume this amount of energy to heat this home based on the way that we've designed and modeled it. So I can come in and I can model a R15 wall and triple pane windows, and that's going to work. I'm going to have a nice assembly that's going to keep the building from consuming too much energy at that point if I'm doing certain assemblies.
And when you say consuming too much energy, means leaking too much energy, really, right?
Yeah, correct. Yeah. When we're talking about, there are three metrics on the BC Energy Step Code. We've got TEDI, which is thermal energy demand intensity. So that's your amount of heat that you're using, heat energy to keep the building at your design condition throughout the year. Then we have mechanical energy usage intensity, which is MUI, and that's how much you're using for your mechanical systems, your HVAC, your heating and cooling systems, and domestic hot water. And then you have your air tightness level, which is something that we determine with our blower door. We pressure test the building to make sure that it's good and airtight. So those are the three values that we're looking at primarily in the Energy Step Code. And then it gets progressively more stringent as we move through time. So now, just as of this spring, right across the province, everybody is at a minimum of Step Code 3, and we'll move on from there.
And the maximum, like that, where we're trying to get to is Step Code 5. 1 through 5.
Yeah, we're heading for BC Energy Step Code 5, which essentially means that every new home constructed in BC, as well as there's provisions for commercial buildings, but every new home constructed in BC will be what we call net zero ready. So that means that you're efficient enough of a home that if you slap some solar panels on top to match the size of the home, that you will produce as much energy as you consume on an annualized basis.
Okay. Now, when they implemented this is, 6-7 years ago now?
I wasn't in the province when it first came out.
Okay.
I think it was 2018 was when BC Energy Step Code came in, but I could be completely wrong on that.
Okay, so as someone who's been, I've been building residential single-family homes and duplexes and fourplexes for the last decade. And so one of the biggest changes for the consumer, and I guess for money outlaid in designing these homes when Step Code came in, was you used to be able to have a draftsperson design your home. There'd be a standard wall assembly that you would come up with. And you could take that plans from that designer and you would go out and talk to a couple of builders, and the builders would provide a quote for that. But what would happen very quickly when step code came into place is that when you design these plans, if you didn't have an energy advisor involved in designing of those plans, you would take them out, you could shop builders, you would find the builder, then you would need to get the energy advisor involved because they had to, like a structural engineer and a geotech, they have to submit a report with that plans to submit for building permit plans. And your wall assembly could be different. Your windows could be different. Your HVAC could be different from what originally would have been totally fine prior to step code. And then your costs and things would change. Mm-hmm. And so that from a design and from a builder's perspective was you needed to have this energy advisor involved right off the top in design. Just to understand what that combination was going to be in order to achieve step code 1, step code 2, now step code 3.
Yeah, in the beginning, the metrics have been really, really easy, I think, to achieve, honestly. Right now, we're at minimum step code 3, so that's the minimum value right across the province. And pretty much any house built to the prescriptive code is going to hit step code 3 as long as they hit their air tightness. It's very, very close. Sometimes it's like if you've got a big box that's just all glass, you may need to add low E coatings or something like that if you've just got double pane windows. But if you're building a reasonably good house and you're hitting the air tightness target, you're going to hit step code 3. It's not that challenging right now.
Well, and I mean, it's been 8 years of changes of construction technique changes that I say 8 years. I'm not exactly sure on the exact length of time, but sure. Approximately. And it's been trial and error and builders developing new techniques and new best practices. And now here we are at step code 3. Now we are venturing down the path to step code 5. What year is that mandated in BC?
2030 or 2032, I believe.
Okay, so we've got 5 to 7 years before mandatory step code 5, which, as you were mentioning, net zero ready. So the home can use as much energy as it could potentially produce if you were to add.
Yeah, with an appropriately sized renewable energy system, that's where we're kind of going for. The reason that we're going for this is primarily a budgeting thing in my mind. We're looking at infrastructure costs that have gotten pretty out of control in the world in general, but in BC as well. You know, we just finished. They're filling Site C Dam right now. I don't know what the final number was, but I think between 16 and 17 billion dollars, wasn't it? Or between 16 to 17, I think, right?
I have no idea. It's just, but if it's government, it was a lot.
Yeah. So we're looking for energy efficiency because we want a resilient network, right? So that's kind of where we're heading for that. We want to reduce those ongoing energy loads so that we don't have to build a whole lot more infrastructure.
And this is a big conversation in the industry. I mean, I was just listening to the station on the way in that by 2030, we want to be selling all electric cars. But everyone's like, how are we going to charge the cars? Where's all this power coming from? What's happening? And what's happening is Fortis is giving a lot of grants. They're putting a lot of money out there right now for individuals to be retrofitting existing homes, making them more energy efficient. Yeah. We're pushing towards all new construction to be more energy efficient. And that's how they're trying to counterbalance the push for us all to be using electric power. Is it going to work? I don't know. We'll see. When we come back, though, we're going to talk about existing homes and tips and tricks, what you can do, and dive into those grants that are out there for you. Stay tuned. Welcome back to The Real Build. I'm your host, Jamila, and today we have Ben from Station Craft. He is an energy advisor, and we are actually working together on a project, and we are talking today all about energy consumption, what you can do to create higher energy efficiency in your existing home, as well as the codes and guidelines that are coming down in new construction and how new construction homes are more efficient than ever. So what I would like to dive into is the existing home. And Fortis has a lot of rebates out there right now for people.
They do.
And I want everyone to go out there and take advantage of it.
And not just Fortis, but Clean BC as well has a lot of rebates.
Beautiful. Ben is going to clarify these and make sure we understand how to go and get these.
Oh, okay. Well, as long as I don't have to do math live on air, then I'm good. But
we should be okay. Now, if you have an existing house and, it's time to get a new furnace. I'm actually in this situation. It's time to get a new air conditioner for me.
Yeah.
What should I be thinking about?
Ooh, that's a loaded question. Generally, what we're looking at for improving the efficiency and making sure that you get the best bang for your buck when we're looking at upgrading an existing home, we're looking at primarily first identifying where your home uses energy and then addressing the load side first before changing equipment. So for me, like I said, in construction, understand a lot about buildings and how they're put together. Mm-hmm. We're looking to identify the areas where your building is wasting energy and costing you money unnecessarily before putting in new equipment. So if you've got a 100,000 BTU furnace in there right now, and that's keeping up and keeping your home heated, well, when it comes time to change that equipment, if we can analyze the building and drive down the demand side, we can put in smaller equipment and make sure that you're not using as much energy, as well as saving money on the upgraded equipment first.
So how do I do that? Like, I'm a homeowner, I'm thinking, hey, I want to figure out where I'm leaking. Where's my loss? Who do I call?
Yeah, I mean, you can call an energy advisor to come in to do an EnerGuide file. That's somebody like me, or there are plenty of energy advisors in town who will come in and model the building for energy usage, check out all the equipment that's in the building, pressure test it, and then model it in an energy consumption software. Mm-hmm. And then we look for the best pathways to driving down your energy usage. I tend to think that in older homes, the primary driver is air leakage, mm-hmm. and everybody seems to think that means windows and doors. Sometimes it does. Sometimes you need to replace seals or replace entire units. But more than likely, there are just a few areas in your house that are really, really leaky, and you're just pouring conditioned air and money out of those holes.
How do I find these holes?
Well... I'm not trying to sell my services here or anything, but you get an energy advisor in, you do a blower door test, and you make sure that they have thermography equipment so that you can do it on a cooler day when they can go around with the blower door running and the house in a depressurized condition. You can then see that cold air where it's coming in everywhere.
And then what? Do I just grab a spackle and spackle up that area?
It's different for every spot. Sometimes there's big open holes. Electricians in particular really love drilling big holes to push a small wire through. Mm-hmm. There's a lot of that type of stuff, but it's different on every build. We're looking for where the air leakage is occurring, or even if air leakage is the primary driver of your energy loss. A lot of times there are other things. You can very easily add 12 inches or 10 inches of blown-in insulation into most attics and really drive down that energy loss, right? Mm-hmm, mm-hmm. The big ticket items are the mechanical upgrades and the windows and doors. Those are big price tag items. Mm-hmm. So I would prefer to find a strategy that drives down your energy usage by 10 to 20% with a couple cans of spray foam and a couple tubes of silicone, rather than having you then pay $30,000 to upgrade equipment, right?
Yeah, and you talked about the blown-in insulation in the ceilings now, or in the roof. And a technique people use in new construction now is a high heel truss, mm-hmm. which gives you a bit more space in the corners of your roof to pack a bit more insulation.
Yeah, it gives you a greater degree
edge
of insulation depth at the edges of your roof line, yeah.
And the older homes that wouldn't have this, and of course your blown-in fluffy insulation does compact over time, this could be a simple thing to just add some more and get it back out to the edges. So that's a great tip.
It can be, as long as you're hiring a reputable company. A lot of people want to do this type of work themselves, and that's fine if you know what you're doing. Mm-hmm. But I've also seen a lot of instances where people will rent that machine from one of the box stores and buy a bunch of insulation and go up there and blow it all around, and they end up blowing it too far into the eaves without installing baffles. Mm-hmm. And then all of a sudden those vented soffits you have all the way around the perimeter of your building are not venting, and then you start getting attic rain and you start getting all these different problems. So you do have to go into it with a good idea of what you're doing.
Now, one company, I've used them before in new construction, and that is where they come in and we would do this at drywall before we start finishing everything.
Oh, you're about to shout out Sebastian, aren't you?
Well, I was going to say a specific name. But they come in and they seal up everything, and then they blow a small microfiber through the air.
Yeah, it's an aerosolized silicone.
Yes.
So basically they'll come in with a blower door like we use for our evaluations, and they will pressurize the house in this case. Mm-hmm. And then these stands aerosolize silicone into the air, and the pressure differential pushes all those little silicone fibers into all the tiny little gaps and cracks in the building envelope to seal it up really nicely. You're not going to get them to do that on an existing home, though. Okay,
that was going to be my question. Is that something that you can do in an existing home that just
seals
everything
up? You can, but it's
up?
so cost prohibitive. You have to mask everything off, protect everything, and I just don't think anybody's going to... Well, I mean, you could call around.
Okay, so I mean, it could be an option if you do your testing and it's literally just your seal. Like, people could have a 20-year-old home that has great windows in it and great doors, but wasn't built under the standards of how we seal up houses today, and that might be the key.
It could be. It's going to be very cost prohibitive. Okay. For me, I would rather see somebody going through with a thermal camera and identifying those leaks and trying to get the low hanging fruit. You're not going to make an old building perfect. You want to improve where you can, without being too destructive, right?
Yeah. Now, when Ben and I usually have conversations about costs and efficiency, I'm the one saying it's too expensive, and he's the one saying we should do it.
No,
so
just do it.
If he's saying there's other ways, there's definitely other ways.
Yeah, absolutely. Well, and I mean, we talk about that. That's kind of the push and pull when we're working on a project together, right? Mm-hmm. Like, I want to push for things to be as efficient as possible, but I'm also trying to do it from a buildability standpoint, right? So Jamila does have to push back on me with certain things because I've got stars in my eyes and I want to see certain things. But
there's a balance between the perfect building and it being feasible to build, because financially you can do it, right?
Yeah. New construction is a completely different beast from existing construction.
Yeah.
I'm often pushing for things that I think are smaller upgrades in the grand scheme of things, but that's where the relationship has to be. We have to be able to talk to each other and push back against each other, right?
Totally.
Because I need things in the energy budget for the building, and you need things in the actual fiscal budget, and we have to be able to work together and balance those out to get the best project possible.
But basically, it's still more important for the kitchen cabinets than the seal these days. Yeah. But we're going to keep talking about this. I wanted to talk about all of the rebates that are out there, and that's going to have to come up next. But there is tens of thousands of dollars of rebates available for existing homes. And I'm actually using this on one of my rental properties right now to see what it's all about. But when we come back, we're going to talk about the rebates available for existing homes for increasing your energy efficiency, and we'll dive down the rabbit hole of new construction energy efficiency. Stay tuned. Welcome back to The Real Build. I'm your host, Jamila, and today we have been talking about energy efficiency and BC Step Code. My guest, Ben Station, has been filling us in on all the tips and tricks with doing home renovations and increasing efficiency, what increasing efficiency means, what you can be looking for, where you start that process. When we left for the break, we said we would come back and we would let you know about rebates available for renovations. So existing homes, you want to increase the energy efficiency, and there is money at your fingertips. Ben, can you tell us a bit more about what's available?
Yeah, there are 3 main programs that we work with in this area. The first one is the federal program. We have the Greener Homes Initiative federally that's still providing the grants have gone away, but we still have an interest-free lending program that is there providing people $40,000 of interest-free funding for doing energy efficiency upgrades on existing homes.
Lovely.
Yeah. So in that case, you have to hire somebody like me, one of the energy guys. You got to get an energy advisor in, do an EnerGuide file, and then we provide a pathway for your energy efficiency upgrades, and then you get them approved federally. So they will provide, up to $40,000 for doing that type of work, which can include things like adding solar panels or increasing insulation, windows and doors, that type of thing. And it's 10 years interest-free, so it's a really, really excellent program. And then we also have provincially here, through Clean BC, we have a lot of different rebates, and the programs are numerous and complicated. So I always just tell people to go to Clean BC's webpage, and there's a phone number there that you can click on, and you call up, and somebody just picks up right away, and they answer all of your questions about the rebate programs, and they know everything. They're great. They're awesome over there.
You can get a human on the phone in 2024?
Last time I called, you don't even go through a menu. You just call and somebody picks up and then they know all the stuff. Awesome.
I don't even know if I'd be like pressing 1.
They've probably diverted it to some sort of AI thing by now, but no.
Okay, so can we say that website again?
It's Clean BC. I'm not sure the exact link, but if you just go to the Clean BC website, you can go and look at their rebate programs and find the 800 number and just call and talk to somebody in their office.
Yeah, and it's not like, $100 here and there. There's thousands of dollars.
Right up to almost full funding for certain things. There are different income qualified programs too. So if you're low income, you can get greater levels of funding for these types of initiatives.
Mm-hmm. And, I love it when there is a huge motivation to reduce energy consumption because we are running out of power. It's not infinite. And they've created a lot of incentives for you to go and start doing those upgrades to the home. So not only is there cash back in your pocket, interest-free loans, you're increasing the value of your property and your home.
Yep.
And you're increasing the living conditions, just the general day-to-day life living conditions of your home.
Increasing the comfort of the home and also helping the rest of us save money. Like I always present it as I like these programs as a taxpayer because I know how expensive it is to upgrade infrastructure. So the calculation is that we can put money in people's pockets, drive down the energy usage in their homes, rather than using that same money to upgrade to deliver the extra power that then needs to be wasted. It's just...
So go to Clean BC and start your renovation today.
And also go to Fortis's website, because Fortis has a lot of really good upgrade programs and rebate programs for existing homes as well as new homes.
And if you want to take it to the next level and get started, call an energy advisor.
Absolutely. And City of Kelowna just brought in another program called the Home Energy Navigator, I think. So you can call the Energy Navigator and they'll help talk you through the different rebates and processes and get you connected to an EA and all of that.
So if you want to hear all this information again, we are going to post this episode live on the YouTube channel, The Real Build on YouTube. If you can head there and you can hear this all again. But I want to talk about new construction. All of this stuff is now being implemented into new construction, new builds. Ben, tell me, going from Step Code 3, now jumping to Step Code 5, it's big. And there's a new process, the integrated design process.
Yeah.
Which you and I have actually just started doing one together.
Correct, yeah.
And this is more than just you're a carpenter, you framed walls, you've decided to become an energy advisor, you do blower door tests. Now designing the mechanicals of a home.
So
Tell me about this.
I'm much more of just a general building science dork than an energy advisor.
Chief construction nerd?
Chief construction nerd at Stationcraft, absolutely. This is something that I became very interested in a good number of years ago. And once you meet somebody who's gone down the rabbit hole of building science and high performance building, we're all very much the same in our dorkiness for this type of subject. I saw a lot of value in learning how mechanical systems work, how to build them, and how to design and put them together. And so I just started educating myself on that. Same thing with the building envelope and the science of assemblies. I did a lot of schooling on that, and it made a lot of sense to me with my building construction knowledge. So I combined it all together, and then in working with an energy advisor on my own home, actually, I realized that, being an energy advisor is like right up my alley. So I added that on and brought everything together and built this company around trying to have all of these different processes that impact each other so much in the course of building, trying to bring them all together and make it so that there's a one-stop shop that you can go to have your building designed from the ground up with all of these different construction techniques as well as energy consumption in mind right from the very beginning. And then earlier this year, the new Fortis rebate program for new home builds came out, and I realized that I had all of the qualifications to be one of their certified experts in all of this. So it almost felt like Fortis released a rebate program just for me.
Perfect timing. And, to talk to that, so these rebates in new construction, and this is part of the government wanting us to go from Step Code 3 to Step Code 5. It is a big jump in construction standards, the details that go into the design of the wall assembly, the penetrations,
the thermal bridges, all of the mechanical systems, and how we get to these lower levels of energy consumption. And you're completely correct. It is a large jump to get to Step 5. That's why the Step Code was developed this way, so that it progresses little by little, and the industry can learn, and builders can learn, and everybody can learn together as we get better. And so they're offering a lot of rebates for people who want to jump ahead and start building to the best possible practice now. So that's what we're doing. We're targeting for Step Code 4 and Step Code 5 builds to drive that down right now. And, if you're in the Fortis delivery area, if you build to Step Code 4, they're going to give you a $15,000 bonus once you achieve that in order to offset some of the costs. But for most people, it ends up just being a reward. So you utilize some of that in your building budget, but $15,000 to get to Step Code 4 and $20,000 when you reach Step Code 5, and that's per unit.
Now, the reason why you want to do this integrated design process is that I talked about it earlier. When Step Code started, you would work with your designer, you would design a house, you'd go out, you talk to a couple of builders. Those builders would get you some quotes. Your plans probably would not even be sent off to a framer or an HVAC company or a window company at that point. You're just getting relative numbers.
Yeah.
Now we have Step Code implemented. You need an energy advisor to come in at the design process, do an energy evaluation, which is going to give you your combination, your wall assembly, your HVAC combination, your window combination. It's been pretty straightforward once you figured out that combination. There's some differences depending on which way your house is directing and how many windows you have, but ultimately builders now, over the time this has been implemented, have found their new combination of how they pull it off. Well, the thing is we're going to a next level of combinations of how to pull it off, and this needs to be incorporated into your plans off the top, and there needs to be conversations with your HVAC contractor, your plumbing contractor, your roofing contractor, your exterior contractor, your insulation contractor. And these people need to be involved in the planning stage. And this is what they're talking about with integrated design.
Yeah.
So it couldn't be more important than ever to have your builder, your selected, your trades team selected, your energy advisor selected, with your drafting person.
Yeah. You want to, if you want to have the highest chance of success and reduce the costs of actually getting to these higher efficiency builds, then it has to start with a proper planning process, right? Like anybody who's ever built a custom home who's listening to this right now is going to know about the change orders and the overages in the budget, right? This is a common thing, and it's not normally because builders are doing anything wrong. They're just doing things the way that they've always been done. Well, what we're trying to do now is come in during the plan drawing process and work collaboratively with the builder, with the client, with the draftsperson, and with the trade teams. And as an integrated design process facilitator, it's my role to bring everybody together and to interrogate the plans and figure out what's going to be a conflict and find these things that are going to be costly change orders later on and address them before the plans are even submitted for a permit. And that includes designing the HVAC system so that we know where every bulkhead is going to be, so that we don't have a client who is all of a sudden upset because a big bulkhead got dropped into the middle of their open span basement, right?
Yeah.
So it's all those things, bringing them together to make sure that everybody is working together right from the very beginning.
Now, we could do an entire show on just new construction, step code, integrated design,
Yeah, if you get me
where
going,
it's
yeah.
going. I think I want to invite you back to do that.
Love to.
Amazing. There's so much going on in energy efficiency. I think we have delivered a really good tip of the iceberg of what's happening in BC and where things are going. What's that website again?
The Clean BC one? Or
Yes. Clean BC. Go to Clean BC. Figure out what your rebates are. If you want to hear this again because you missed something, go to our YouTube channel, The Real Build. Thank you for tuning in, and we will see you next Tuesday.
Thank you.